Hello friends, this video on coordination compound part 26 is brought to you by examfear.com. No more fear from exam. Let's take the next one PtCl2En2 2+. So here we can have an En here and we can have an En here and we can have a chlorine here. That is one possibility. Can we have chlorine apart from each other? So let's try. Let's put chlorine here, one chlorine here, and then we can have these En here. Okay? That is also one possibility. Sorry, this is C2O4. Oxalate, one oxalate here, one oxalate here, one oxalate here, one oxalate here, and this chlorine. So this one, two chlorine are apart from each other. This is called trans, and this is cis. This trans, if you form a mirror image, it will be exactly same. Thus, this is not optically active. But we are asked to form optical isomers, so we can ignore this part. We can ignore this, right? Cis is optically active. If you draw the mirror image of this, and what you get is this guy is 1, and here is 1. So one of these will be levorotatory, the other will be dextrorotatory. Similar to, sorry, this is not, there are two Cl molecules. Here we have a Cl and here we have Cl. Sorry, mistake on my part. CLC. If you see, in this case, this will be by platinum, central atom. Okay, and this is the one will be devorotatory and one will be dextrorotatory, but the other will be levorotatory. So these are my optical isomers of PtCl2En2+. Okay, the next is we have to draw the optical isomers again of CrNH32Cl2En. So if you see number of see the coordination bond, coordination number 2 plus 2 4, and 1 En is didentate, it will give again 2. 2 plus 2 plus 2, that is 6. 6 is what? Octahedral. So it will be octahedral shape. That is something we know. So let's start with the shape. So we have 2 ammonia, 2 chlorine and 1 En. So we can draw various possibilities actually here. See, one case can be 2 ammonia are together and then 2 chlorine are together. And the other case will be En here. Other case can be 2 ammonia are separated by 180 degree. But in this case, if you separate 2 chlorine by 180 degree, you will not be able to form. If you separate 2 chlorine here, you will not be able to form En. So let's have En like this only, and we'll have chlorine here and chlorine here. Other case, you actually separate these 2 chlorine molecules by 180 degree, and these 2 ammonia molecules together, and there is an En here. So only 3 possibility I could think of. We have chromium molecule in the center. Okay, so with this, can you think of more possible geometrical isomers? First, because for optical isomers, although we do first find geometrical isomers. These are the only 3 things I can think of. See, En has to be together. You can't separate them by 180 degree. It has to be 90 degree, right? One, this carbon, this bond, and either this bond you have to take, this bond, this bond, this bond. I took this bond. This bond is done, so you are having 4 remaining bond. 4 remaining bond, you either put 2 ammonia together, 2 chlorine together, or 2 ammonia separated, 2 chlorine together, 2 chlorine separated, 2 ammonia together. So 3 possibilities. Now for all these possibilities, let's see if the mirror image is possible, because optical isomers, it has to be chiral, and let's see if optical mirror image is possible, right? So let's find the mirror image for all these. For this case, it will be one EN here, correct? And then we have one CL here, and one CL here, one CL here, and these two will be NH3. And this is my platinum, chromium center. Is this superimposable? No, you can't superimpose it, right? So it is optically active. I can say these are optical isomers. Let's see for this case. Okay, let's draw again. This will be EN, and this is NH3. Cl, this is Cl, this is NH3. I'm just drawing optical mirror image. Is this superimposable? No, actually, if you just put this here, it is not superimposable. Not so. This is also optically active. Let's try this one. This is En. This is chlorine. I'll put a chlorine here. So En was in this bond. Okay. Chlorine. This is chlorine here. This is NH3 in the bottom. And then I have NH3 here. And then I have one chlorine here. So here also if you see these are not superimposable. Chlorine is 180 degree to each other. There is no bond here. These are also if you see non-superimposable, and these are also optically active. So you can say these are the optical isomers of CrNH3 to Cl2En. Okay. Let's take some more examples. We have to now draw both optical and geometrical isomers of COCl2En2 plus. Let's first draw the find the coordination number 2 En2. Each will give 2 because they are didentity ligand. 2 into 2 4, 4 plus 2 6. So coordination number is 6. 6 is octahedral. Okay, 2 chlorine, 2 En2 molecules. So one option is 2 chlorines are apart from each other. In this case, you can put one En here, one En here. One option is 2 chlorine molecules are next to each other. You can put one En here and one En here. Only 2 geometrical isomers possible. Out of these, let's see both the case we can find optical isomers. For this, let's draw a mirror image. So chlorine will go up, chlorine will go up. This En will form a bond here, and this En will form. These two are superimposable. That's means this is not a optical isomer because these are already exactly same. Let's talk about this. The Cl here, right? There is a Cl here. There is a En bond here. There is an En bond here. So you see these two are non-superimposable. Yes, so this is optical active. So geometrical isomers 2, optical isomers again these two. These two are optical isomers, and these two are geometrical isomers. Okay. See, for geometrical isomers, I think you pause this video, spend some time and try to see if you can actually make more geometrical isomers. When you see you'll not be able to because of the symmetry. There are octahedral, you see this octahedral from this side, you see the same thing, that you will see one straight, 2 left, right, and 2 top, bottom. You see from this side, you see the same thing, one straight, one left, right, one left, one right, one top, one bottom. You see from this side also you will see the same thing, one left, one right, one straight, one top, one bottom. From here also if you see one straight, one left, one right, one top, one bottom. From here also you will see one straight, one left, one right, one top, one bottom. And that's why you don't get so many geometrical isomers. Correct? For example, in this case, even if you try to make something like this, these chlorine you have made straight in this fashion, right? You make chlorine in this fashion. And then you form bond like this. Okay? So, but here you see this is exactly same as this. Because if you view this chlorine from this side, and if you go, this coordination compound from this side, and if you view this coordination compound from this side, both are same. Let's see. From here, you see a chlorine. You see a chlorine. You go straight, you see a chlorine. You see a chlorine. On the left hand side, you see 2 atoms bonded with the En. On the left hand side, you see 2 bonds with En. On the right side, you see 2 bonds with En. On the right side, you see 2 bonds with En. Just visualize this. Okay? And that you will not find this symmetry in other complex, but in this case, in tetrahedral, we have less number of geometrical isomers because of this, because of the symmetry of the structure. Let's see. We have to again draw the geometrical and optical isomers of CONS3 ClAN2. First, let's find the coordination number. This is 1, chlorine is 1, this is bidentate. 2 into 2 is 4, 4 plus 1 is 6, 6 is again my octet. Okay, so now we have to find the number of isomers for this, geometrical and optical isomers for this. So let's see what we can do. I have these two different now. Chlorine, they are not two chlorines. Earlier it was two chlorines. Okay. So, see, let's put one ammonia here. Then I can put the next chlorine here. And the next two EN we can put here. Let's put one ammonia here and then one chlorine here. Okay. See, if I put one ammonia here, putting chlorine either I can put here or here. Both are same. I mean, both are different case. But if I put here, it is all same. So I have option to put chlorine is all same. Right? Two possible options of filling ammonia and chlorine. Now, the next option is putting EN. So putting EN in this case I can put here. Is there any other possibility? No. If I put this two fashion also, it's all same. Right? Because from ammonia angle, if you see from ammonia, if you put in this side and this side, you will see that one on the left, one on the right. Here also if you put, if you are viewing from ammonia, one from left, one on the right. So it's all same. You put here or here or here or here. You get the same coordination compound. In this case also, let's see what option I have. One option is, I can put this here and that is one possibility. Now the question is there any other possibility? See, from the ammonia angle, if you see, if you go straight, you are finding two EN. I mean, this one is EN with this angle and this. It's all same actually. Even if you bond like this and this, you will actually, when you visualize, you will see all same. Example, let me draw it for you. H3 and Cl. Now instead of forming bond here and here, what I am doing is I will form a bond here, which I can do, and I will form a bond here. It's like this. Here also if you see, both are same actually, because from the ammonia perspective, you start with ammonia, you see a chlorine on one side, and then two of the bonds are EN bond. Here also you start with ammonia, there is a chlorine on this side. Two of the bonds are EN bond. Okay. Then if you go down, there is a bond which forms a bond at 90 degree with the EN. Here also same thing. Go down, there is a 90 degree bond. It's all same, both are same actually. So only two possible geometrical isomers. Let's see optical isomers. Form a mirror image of this. So what you get? NS3 will be on the top, Cl will be on the bottom. This will form a bond here, EN, and this will form a bond here. So if you see, both are actually superimposable. So they are not optical. Right? They are not optical isomers because they are superimposable, they are same. Correct? So they will not be optical isomers. Let's talk about this. So we'll put NS3 here, and then Cl will be here. Okay, and then these two bonds will be these bonds. These two bonds will be. So you see, these two are non-superimposable, and thus you can say it's optical. I'll tell you, pause this video for some time, visualize how many geometrical isomers you can form, think, then you can understand the concepts. Even if I say like this, you won't get the concept. Just try for any compound, just spend some 30 minutes, 1 hour, 2 hours, and just try to find how many possible geometrical isomers you can make. You'll realize that after some point, you are making the same structures. So this will come with practice. You have to practice. Okay. So the next, thank you. Visit examfear.com to watch more videos, attempt free online tests, get free study materials, find tutors and mentors, and much more. Thanks once again.